Hey everyone, welcome back to another episode of TinkMakes. We haven't done one of these for a while, Andy.
Yeah.
And we thought we would do one, but we mostly have been focusing our attention on skills content, developing content for really getting industry, 3D printing industry knowledge out to, well, anyone that wants it. But in the process of filming that information, we realized that there was a project that we did that just really started to creep up on us in terms of annoyance. And that's the project behind us, the camera arm. We did this project really quickly, in a matter of like days actually.
Yeah.
And I think at the time we gave ourselves a constraint of using whatever we could
Yes.
find here.
Yeah.
Short of the extrusions and whatnot, and I guess the airline cable, and just throw it together so that we have a camera arm that is more versatile than what we had, which is a tripod and a camera. And
Wasn't a very good idea.
I would say that, well, I think while we learned a ton of building this guy, we just did not do the proper engineering and design behind it, or gave it enough time to really make it a good project.
Yeah.
And
I mean, it's still a very good project. I mean, it still works. It's just, I guess, right now we're finding out the minor drawbacks that we're having every time we're trying to set this thing up.
Or like the little flaws.
Yes.
And so, yeah, I mean, we're going to go through this, and then we're going to address the design.
Yeah.
I'm going to show you kind of how we go about doing it. This is version 1. I'm going to call it We're Making version 2.
Yeah.
There was a lot of good about this and a lot of bad.
Yeah.
We're going to try and hammer out as many of the bad as we can, and we'll make a version 2 that is way better. We also saw in the comments some people were asking for the files.
Yeah.
So we're contemplating and deciding what we're going to do with this. And chances are, there's a chance that we're going to make this open source.
Yeah.
So that anyone that wants to build a project like this can build a project like this. And yeah, maybe if people want to even, or if they're interested in grabbing the hardware, because we can source that pretty quickly now, for us to just supply that, and then you find your own, 3-inch extrusion locally to you and build your own arm. So yeah, as we said, there's a little bit of nuance with this.
Yeah. So I guess we'll show you what it is, and then afterwards how we're gonna tackle it and fix it up.
Yeah. Let's go. Okay, so one of the biggest issues with this whole entire arm assembly is this main housing here, all these green components. They used what we had on hand, which were mostly M3 and M4 fasteners, machine bolts. And they just weren't adequate for the size of object this was.
They're a bit too thin.
Yeah, and
everybody can see that wobble right now.
That's not good. And we just didn't constrain this properly. This little piece up here that is supposed to wedge and hold that down just wasn't adequate. And that was really an afterthought.
Yeah.
We actually printed this housing twice in the original video that you guys didn't see. But that should have been built in day one.
Yeah.
Right. These little M3 fasteners really should have been an M6 or an M8 fastener. For all the Imperial guys out there, I think they're a little bit over a 1/4 inch in size. But right now, these are 1/8 inch in terms of its size.
And if we change it, it'll be a lot more sturdier.
Yeah. So that was this is one of the biggest issues with this whole entire assembly. Right now, it doesn't really move, but as I extend this arm out,
you can see that it starts drooping
towards the side.
Yeah.
That it's moving towards, and that means when we were doing pan shots, it just requires an extra layer of editing.
Yes.
When we're talking, because this is actually missing a screw that's supposed to go there. It slowly creeps forward.
Yeah.
Just wasn't well planned. Got the job done for what it was at the time, but this really requires us to just give it some attention.
Yeah.
Right.
I mean, for a 2-3 day project, I think we did pretty good.
I think this whole entire thing took 2-3 days.
Yeah. For a 2-3 day project.
We put a day into designing this really quickly, pulling some raw dimensions from the steel, or not the steel, the aluminum extrusion. But this could be optimized and shrunken down a significant amount, more dense, a little bit more constrained, actually a lot more constrained.
Yeah.
And we have no ability right now in this design to well, get into the bearings. They're hard fixed in there.
Yeah, they're stuck.
So changing those to, M8 bolts will be ideal for making sure that they stay tight. And so like this is the main issue that we want to address.
Yeah.
And then there's a secondary issue.
You see it wobbles quite a bit in the base. So we are thinking of coming with a new design to help secure it.
Yeah, brace that base better so that it doesn't, do this
Wobble.
when we're moving it around. And this is the inherent issue with just having a fixed anchor on the bottom. There's no brace. It's literally held in the middle of the board that is there. So I think once we add a couple braces, that disappears.
Should be eliminated.
Yeah.
I mean, I think another issue is also because I had to convince Eugene of having this very long, the cross rod.
Oh yeah, this is, what is that, 5 feet?
Yeah, I think it was 5 feet. I mean, if you guys are probably not having something this long, I think it would have worked a lot better.
Yeah. So just to kind of give a recap, this whole assembly is 7 feet tall. And I believe the cross arm is 5.
Yeah, 5 feet
if I remember
long.
correctly. Yeah, I think, it worked. We leave little markings on the actual vertical beam for filming heights for different people. But that was one thing that we really wanted to address. It works. It's once you set it up is good, but the creeping of this thing as it moves.
Panning was a bit of a hassle.
Yeah. Yeah, I think the only other thing that we wanted to change was there's a fixturing that is in the front. I'm just gonna kick this over. This is the fixturing that we use for attaching, the teleprompter design. We may even do a bit of an upgrade on this guy. And then there's the other end of this that is also got potential fixturing. I think we're gonna add a second one.
Yeah.
For versatility purposes. But nothing really needs to change about this. It works well. That main kind of housing in the middle, that needs some beefing up.
Yeah.
And some design considerations really put into it.
So, I guess...
I think we're going to roll a bit of B-roll of us just swapping this thing in.
Well, we're going to do designing first. And then swap.
Yeah. We don't have any parts anyways right now.
Yeah, so we'll show you some CAD designs, I guess. Some CADing.
Yeah, I think there may be maybe even some discussions of just how we're gonna go about how to brace things.
Or how to make it, how we made it more sturdy, like what kind of design changes we actually made.
Yeah, and then I think the remainder, I don't think we're gonna do a actual full build B-roll. I don't think that's required where we put the bolts in. Like you guys saw the last one.
Yeah,
that's fine.
So this is probably just gonna be more of a disassembly and just assembly, and then we'll test it out with some B-rolls as well. Yeah, just show you how much more sturdy it is.
Okay, so let's go into the actual design process. We won't do it here. I think we're probably gonna take a break. We spent some time just really looking at this about how we're gonna go approach it, and I can probably share some of that with you right now.
Okay.
So. That main housing, that's the green component that connects the vertical rod and the cross rod together. I think we're gonna really condense it down so that it's not using so much plastic, it doesn't take so long to print. So that's number one. All those bolts, my gut is telling me probably an M8 screw or machine bolt of sorts, and then access to bearings, so we can actually tighten them down. So that they're fully constrained, not just press fitted in there. And then this vertical beam that's here, I'm thinking 4 braces on each side.
Yeah, that should hold up the whole thing without it.
Anchoring that down, maybe at a 45-degree angle or 35-degree angle, and that's gonna make us lose a little bit of vertical height. Like we won't be able to go as low as we want to.
But so far we haven't had the need to go down that far.
Yeah, just wait until the day that happens, and then we'll be talking again.
Yeah.
The overall, I think, process, the CADing side, once we have all of the things that I mentioned out, should be fairly quick. So taking the concept of what we just said, all those adjustments, doing the computer design work, should be a couple days, and then it's all about tolerances and fit. So yeah, I mean, we're doing FDM. We're gonna do this really quick. So we're gonna use the rough settings for our printers, and then we're just gonna go and see what that turns out into. We'll probably have to do a couple takes, especially on the tight fitted stuff.
Yeah.
But majority of it should be fairly straightforward.
So we're not gonna be completely showing you every single step of assembling this. It's just probably just gonna be a general disassemble, assemble, test it out, give you B-rolls.
Yeah. We'll probably see like a swap video, a B-roll of the swap, a time lapse of the swap video, but we won't be showing you. You know, I think we did
Every
the
single thing,
per bolt of this original one. I don't think you guys are interested in that. If you guys are interested in, will be in the last one.
Yeah.
And then the only thing that isn't changing about this whole entire system, the counterweight system that goes inside the tube, we're gonna leave that the same. I don't think there's any.
Well, we found that to be adequate. I mean, it's not. Yeah.
I think we may have to rebalance the arm.
Yeah, after the weight difference, probably.
Yeah, I can't imagine that being the same. But that's simple enough. We just take a couple rods out or put a couple rods in. And we're good to go. So I suppose the next time you see us on screen, we'll be doing some design work.
Yep.
So I guess we'll see you guys then. All right. So we've been spending a couple days here now designing this arm, going through the processes, and I'm going to show you guys what we've done. And we're going to hand this off over to Andy for all the printing, assembly, and all that stuff. It's just a lot more efficient to do it this way. So I've got in front of me SolidWorks, which will probably make full bleed, probably shrink myself down to the corner. But the arm is pretty different. We have actually condensed the actual main housing significantly. We've gone and changed all the fasteners from M3, M4s to M8s. And there's 3 countersink M6 screws here just to hold the whole entire housing together. It's so much better than what it was before. Okay, so first things first. The crossed arm assembly is significantly smaller. We've condensed everything with really tight tolerances, and it just makes for packaging that is so much more concise and dense. The fixtures are now super constrained, so 3 bolts hold the outside body, I guess the cross arm body, to the main vertical housing body, and then there's 2 more bolts that go 45 degrees anchoring it all down. So there's no more slop and shouldn't be any more slop. The bearings are now accessible by M8s. I think these are 55mm M8 screws or bolts, socketed bolts. Again, allows us for adjustability and just so much better. Everything actually is tightened down with Loctite. And so we didn't want this thing to rattle loose, so yeah, there's that. And then you'll probably see also that the arms now actually have proper tightening bolts, so they don't slide around when we don't want them to. They should have been there day one. Okay, then moving on to the bottom. This is where big components are added for just vertical stability, bracing that we talked about. We'll lose a little bit of build height. Let me see what that actually is. So we lose about a foot, 30 centimeters, 31.7 to be exact. And the arm can no longer go all the way down to the bottom. But I think that trade-off for stability totally outweighs the ability to go all the way down, which we never used to begin with. So you know that you have that. These are the cylinders that we use for the scooter project. We're not going to use a scooter around this facility. It was just a project, so we're going to upcycle them into this project, and we're going to just be chopping them down so that they fit better than them sitting in the corner not doing anything. So these are going to take a while to print. These main housings alone, each of them, if we print them in the faster orientation, about 10 hours. If we print them in the normal orientation, like 12 hours. But the normal orientation allows you to print it without any supports, and everything just comes out a little bit cleaner. After that, it's all assembly. We can put it all together at that point, and yeah, I think we'll have a updated version 2.0 that you guys can see. And If you guys want to build one, I'm pretty sure we're going to make this available later on. Okay. From a design perspective, that's all that I've got. Really, it's about simplifying the actual build process, allowing it for an easier build, and off to the actual printing and manufacturing. Should be pretty straightforward. Okay, handing it over to Andy now.
Okay guys, we finished printing everything, and right now I just want to go over some changes and show you guys what we went through during the design process. First, there's this piece where we had to test the tolerance on it because the rod goes in, and this was actually a bit loose, which then we had to print another one, and that one we needed, because overall we need a snug fit on it. So this loose fit on the first one was a good initial test to let us know whether or not it's going to be a snug fit. And afterwards we fixed it, so now it's a lot better. Doesn't wiggle around anymore, goes right in, very sturdy. Next, I want to let you know, when we were printing these, make sure that you have really good filament, or a filament from a reputable source. It's just because we printed these multiple times, and the filament that we were testing third-party filament, and it clogged our nozzle and jammed it a couple times. And as you can see here, we have 3 failed ones, and we have other ones that we threw out already. But if you think about it, these prints individually took 3 hours each. So with right here, what you see is already 9 hours wasted. So that's just one thing that I think everyone should keep in mind, that having a respectable brand of filament will go a long ways. And then last of all, I just want to show you guys this, the new design here with the bolts. These are a lot more sturdier now, and also the nuts, we also glued it in with just a dab of super glue. It's just to keep it from falling out when we are disassembling or assembling it. And that's pretty much it. We can go ahead and start assembling our new camera arm.
Okay, we just went off screen because there are these little nuts inside that are essentially set screws, or I guess threads for the set screws that we're going to be putting in for holding that little brace together. Yeah, I forgot to put tolerance into this, so we had to hammer them in. Now they're not coming out, so back to assembly. Don't know if I'm in frame, but you guys may recognize these rods. They came off of our scooters, so repurposing them. We don't use those scooters, so yep, they're being put into bracing. Okay, we're done. At least the assembly of it. We're gonna bring you guys in for a close-up shot of everything.
How much sturdier it is?
Yeah, B-rolls probably. I'm happy with this.
Yeah. Well, apparently we were lucky with the weights too. The weights actually balance it up.
Yeah, it's fully balanced. This thing is not set right now, but it worked out.
Yeah.
Yeah. Okay, bring them in for some close-up shots. Mm-hmm. Would have loved for everything to be like clear and black. We just used 2 colors, but I guess the upper pulley system and the bottom bracket system, that'll just be a constant reminder of our failures in the first version.
Yeah. And Eugene's gonna redesign the mounts for the camera and the teleprompter, making it more of a sturdy design.
Yeah, just in general more versatile. So in the future, if you want to add a monitor to the side, there will be holes ready for that. And then we're gonna do it on both sides so that we can have two different setups, so things are a little bit easier to just navigate. Okay, let's bring them in.
Okay.
Cool.
So we're done.
Yeah, I guess outro time. I'm pretty happy with this, Andy.
Yeah.
Like,
you saw some B-rolls earlier, and like I didn't even see it droop at all.
yeah.
And a huge improvement compared to the previous one.
I guess you guys don't realize that we've done some B-roll shots for other videos with this arm, and if you've seen our video on the actual dolly that we automated, the electronically controlled dolly. We haven't used that since we built this.
Yeah, we haven't.
And it was really when we started to do B-rolls and panning shots that we realized that drooping was a big problem.
Yeah.
I mean, of course it would be. Like, why didn't we think about that at the beginning?
It was just a lot of extra work in the editing programs to actually edit that shakeout, that random.
Yeah. This is a good lesson for anyone that's doing design projects, doing design work. That version 1 is never perfect, and version 2 will usually get better.
Yeah.
It's also a very good lesson for those that are doing design work to take that extra time, or even engineering work, take that extra time to just make sure that things are fully constrained.
Yeah.
Constrained, I suppose.
Yeah.
When you're executing on something that requires rigidity and structural integrity. We should have thought about that.
But then if you think about it, technically the first green one was our prototype. We just never went beyond that to fix it.
Yeah.
But most design processes, they'll come up with a prototype and then find out what needs to be improved, what needs to be changed, whether or not it needs to be more sturdy, or the design doesn't work. And then afterwards, version 1 comes out, right?
Right.
They don't
Version 2.
Yeah. They don't actually mass produce the first one.
No, and I suppose you were right. That was a prototype, but we also put a huge amount of constraint behind the project. I mean, if I remember correctly, the episode that we put the version 1 green camera arm out, the whole entire thing cost like $60 to $80.
Mostly, yeah.
This time, we went and bought retail fasteners from like places like Home Depot and stuff.
Yeah.
And it totaled, just for the screws, like 25 Canadian dollars.
Yeah.
That is like a third of what we paid for these beams.
Yeah.
Secondhand, or I suppose on the used market. So it really gives you a sense of when you start doing things right, how much more expensive it could be, I suppose. I mean, $100 for a camera arm of this scale is still super cheap, relatively speaking. And then we never anticipated to sell this arm or give it away. We didn't even think people would care about it. But we had enough people that reached out to us asking if we would sell it, give the plans away. So you'll probably see the plans of this available in the description at some point. We are going to probably make this thing open source. And then do let us know. Do you want us to put together a hardware kit of sorts? Where like we'll get all the bolts, we'll 3D print the parts.
Yeah.
We're not going to ship you these beams. You really should be sourcing them locally to you. Given today's logistics with COVID and shipping, like the project would be blown out, and you should probably be buying one at that point.
Yeah.
So let us know if that makes any sense.
But the files, if you guys do have a 3D printer at home or at the office warehouse, then they'll be open source, and you guys can download it and print it up.
Yeah, this print is longer than the previous one. Each of these 4, I'm gonna call it out bracket pieces, is 10 hours. And each of those little brace brackets are 3 hours.
Yeah.
So the other one was much quicker. I think they were 5 hours or 6 hours per.
Yeah.
But again,
well, keep in mind these are a lot more dense.
Yeah, they are.
Than the previous ones.
Yeah.
Yeah.
Yeah. So I'm happy. I still have some work to do with regards to the 2 ends, the fixturing for the 2 ends.
Yeah.
And we're debating whether or not we just buy a teleprompter for the teleprompter side. We're debating. And if we should just be moving this pivot head onto the other side so that it's a little bit more versatile for setup.
Yeah.
Because setup is a big part of the equation for any video footage that we take.
Yeah.
Setup takes a lot of time.
Yeah.
So the faster we can get set up, the quicker it becomes for all the content we can produce. So we're contemplating it.
Yeah.
At least I'm contemplating it.
Yeah.
Because I think if we were to keep this, that teleprompter will probably require a version 2. And it's not bad.
I think it'll need a version 2.
Yeah. I think that's it.
Yeah.
I think that's
so remember, let us know down, not downstairs, I always say downstairs, but in the comments below whether or not you guys are actually interested in a hardware kit. If we should source everything for you, print everything for you, or whether or not you think the digital files are enough.
Or maybe it's just the build of materials, the bolts,
Yeah.
the bearings, etc.
Yeah.
And you want to print your own file. We haven't fully decided what we're going to do with it,
Yeah.
but if there's enough demand, we will put this up for
Yeah.
grabs. And if you have use for it in your home, if you use it, if you're, I suppose you're an aspiring YouTuber,
Yeah.
or whoever, a business,
Or just a content creator in general.
yeah, this is really versatile for the amount of time that we've used it.
Yeah.
The setup is just so much quicker.
And also just the amount of money that you save. I mean, this one compared to a professional one, I would say the
like
use for it
it's
is
like
probably
a tenth.
Yeah.
It's like a tenth of the cost, if not lower
Yeah.
than that. Okay, let's wrap
so,
this up.
I'll wrap it up quick. Remember to subscribe to our channel and also comment below about the things we just talked about, or leave any comments on what you like us to build in future or anything like that. So we'll see you next time.
Yeah. See ya.
Bye.
Bye.